Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to the fourth lecture. And in today's exciting lecture, with the help of examples on road cross section, stresses and strain relationships, the water consumption in Peshawar University area, and with the help of example of a beam bending moment diagram, we are going to learn how to play with numbers in Python, and again we'll continue discussion on lists and arrays, and also we'll learn how to load files like CSV data files, and we'll learn more about data as well in today's lecture. So let us start by running Python using Anaconda's spider. So clicking on Anaconda, clicking on spider, we will have the spider uploading. So let us start with the first step by creating a list. As discussed in the previous lecture, lists are a list of elements that can be of different types, but arrays are the lists, maybe one-dimensional, two-dimensional, or like this, three-dimensional, of all same type of objects. So let's take an example of water consumption in 5 houses in Peshawar University area. So let us consider that we are interested in these 5 houses and we visited them and we measured the daily consumption, which is commonly known as liters per capita per day, or LPCD. So once we did that survey of these 5 houses, we discovered that liters per capita per day, or LPCD, of all these 5 houses are 155, 160, 120, 170 and 65. So let us create a list of all these items. So list is simply created with box brackets. Let me call this liters per capita per day, LPCD, equals to, in box bracket, let's put these numbers in. So they were 155, 160, 120, 170 and 65. We close the box bracket and press enter. So let's see what is in LPCD. So it is just a list. Notice all of them are integers. We can have different types of values in this list. The next thing to learn is how to convert a list into an array. And for that we need NumPy, and let us import NumPy first. So let me import NumPy as NP, and I press enter to this. Now NumPy is available by the name of NP. So in order to convert this LPCD list into an array, and let's save it in an array called water consumption WC equals to np dot array within parentheses. Now we'll write the name of the list, LPCD, closing the parentheses and pressing enter. This time if you now write WC, which is water consumption, and enter, you will see this is an array. It starts with the word array, while the same thing was list. It doesn't start with the word array. So here you can have some values which are maybe integers, some of them can be string, some of them can be float with decimals. So in list we can have different types of values, but in array, if one type is a string, all of them should be string. If one of them is integer, all of them should be integer, and float, and so on. So that is the big difference. So we learned how, if we have a list available, how we can convert it into an array and then take benefits of arrays. So now let's move to the next thing, which is defining a data in an array manually, but this time with the help of a data type. So for example, in here, let me simply copy this example from here and paste it here and see what it is all about. So this time it is going to create a rectangular array with this first row, this as a second row, this as a third row. Notice none of them have decimal and all of them are actually integers. But if I say type of it is float, it will consider them as numbers with decimal places and it will add a decimal to it. So let me press enter to this and see what is in array A, then notice we have all these numbers with decimals now. Let me press up key and repeat the same thing, but this time with the type of integer. And now press enter. Let's see what's inside it. Notice the difference. This was with decimals, but now this one is in integer. Notice it is an array, so all of the elements have to be of same type. All of them integers or all of them as float. Let me do one last demo on it by actually converting it to type string. So now let's see what's inside. So notice all these values are this time in closed in quotation single quote marks. So they are all strings. In a list, we can have all elements of different types, but in array, all the elements should be of same type. So let's move to the next thing, which is create an array of numbers which are spaced with equal intervals. And here we have numbers from 0 to 10, but then we would like to first of all show the odd numbers from 1 to 9, which are 1, 3, 5, 7 and 9 itself. And if you want to show all even numbers from 0 to 10, so there will be 6 digits, 6 numbers, which will be 0, 2, 4, 6, 8 and 10. So let's see where we need this type of job to be done. So consider this example of a simply supported beam with bending moment diagram shown. So it is a 10 feet long beam with a uniformly distributed load on it of 8 kPa per foot. Now, if on every foot we want to know what is the bending moment, so let us say we calculated that, and on every 1 foot, every individual foot, we have a bending moment known. So at 0 feet, 1 foot, 2 foot, 3, and at 10 foot, notice the bending moments are at simply supported ends are 0, and the maximum bending moment is right in the middle, and for our case, it is 100 kPa. Now, if we want to show the bending moment at all 10 points, or in this case, there are 11 points starting from 0, 1, 2, 3, and all the way to 10. So for all these 11 points, you can see a smooth bending moment diagram. But imagine in our building, there is no one beam, but there are 1000 beams. For every beam, if we have 11 points, then for 1000 beams, we have to, in our software, we have to, in our Python program, we have to deal with 11 times 1000, which is 11,000 data points. It can be much more if you have a more complex building. So in order to reduce that effort, let us say that we want the values of bending moment at every second point, or in this example you can see at every even point with an equal space of 2 feet. So at 0 feet, at 2 feet, 4, 6, 8, and finally at 10 feet. Notice we still capture the bending moment diagram very good, but this time the number of points that we need have reduced from 11 to just 6 points. So 1, 2, 3, 4, 5, 6. So in case of even numbers in 10 feet, we have 6 points. But let's say if somehow we still want to capture the bending moment, but at much lesser points. For example, at odd points, again equally spaced with 2 feet. So starting from 1, 3, 5, 7, and 9 feet. Still we are capturing the bending moment, but here we have missed the values at the support. We are very beautifully capturing the maximum bending moment, which is 100, which we actually missed in the previous case, but we captured the end moments. So there are benefits of reducing points and increasing points, but then how to do that in Python, this we are going to do in the next step. So here again, in this step, we are going to use the Python's NumPy method called Linspace or Linspace. Now the first digit here we write is the starting point, and the second digit is the end point. And then between these two numbers, how many points do we need? If we say 5 points, like from 1 to 9, we need 5 points. Starting from 1 to 9, the first point will be itself. The second will be the 3 feet, 5 feet, 7 feet, and 9 feet. So total there will be 5 points. So in even, from 1 to 10, if we say we need total 6 points, starting from 0 to 10, so the 6 points will be these. So let us start playing with this first of all. So we say A equals to NumPy, for us it is NP dot Linspace. Within parentheses, we need points from 0 to 10 first of all, and from 0 to 10 we need all 11 points. So let me close parentheses and press enter and see what we have in A now. So we have, starting from 0 all the way to 10, this is an array of 11 points. So this is the first case that we were talking about here. So now this beam will have 11 locations, and now whenever we calculate bending moment for them, we'll have 11 values of bending moments here. Now if I write, instead of 0 to 10, I keep it 0 to 10, but this time I say I don't need 11 points, I just need 6 points in it, for example. And press enter to this and see what's in this array A. We have 1, 2, 3, 4, 5, 6 points, but they are equally spaced automatically, again from 0 to 10. And also, for example, if the last case here I need from 1 to 9, but then only 5 points, I can write 1 to 9, and I need 5 points. So press enter and see what's in A. So here we have all these odd numbers from 1 to 9. Of course, if we write 1 to 11 and then 6 odd numbers, then it will give us that. But then in our beam, we don't have 11 foot there, so it will be pointless to play with that. So we have merits and demerits of using even and odd in this particular example, but you have to think how to work with it. So let's move to the next case, which is how to create an array of a matrix which is full of a constant. For example, here we have a 2 by 2 matrix filled with 3 everywhere, which may be required at some time. For example, here if I say A equals to NumPy, which is NP for us, dot full, a matrix of 3 by 3 size, and to tell the size we have to close this in parentheses first. So this is the size, and then next we write what should we fill this matrix with. So let's fill it with 4.5 for example, and I close the parentheses and press enter to this, and this time see what we have. So we have a 3 by 3 matrix which is filled with 4.5, or maybe if you want to just get it filled with number 1 only, so write A, enter, so all of them are 1, and if you want all of them to be 0, so all of them are now 0. Next, if you want a unit matrix, which is very common in matrix applications, we just simply write I and the size of a square matrix. Of course, we just need only 1 digit for that. So let us create A equals to np dot I means 1, a unit matrix, and within parentheses we'll now write the size. Let me say a 3 by 3 unit matrix, and let's say what's in it. So it is a unit matrix. So let's see one example of it. For example, in this case of stress and strain, we know stresses are equal to strain multiplied by this matrix. In it, the first value is actually E over 1 minus nu square, but for our example, let's say this is a 3 by 3 matrix that we need to create for us. So here we'll have 1, here we'll have 0, and here we'll have a value of mu, which is the Poisson's ratio. So let us create mu first of all for our case. So here we have matrix A. Let me show the value again. So A, first of all, we created a unit matrix because cleverly I can see in the diagonal we have most of them are 1. And here we have zeros everywhere else except in these two places. So in unit matrix, we also have in the diagonal 1 in most places and zeros in these locations. While here in these two values, we would like to have them replaced with mu, and this particular one to be replaced by half of 1 minus mu. So let me first of all write, for example, for mu, I'll use v equals to 0.2. So I'm putting some Poisson ratio value in it. And now let me start replacing these some values in matrix A as required. So in matrix A, the first row, which is 0th row, but this is the 0th row, but the second column, which will be 0th and first column, so 1. This will give us the value or location of this place, 0th row and first column. So 0, 1, 2, 0, 1, and 2. So now I want it to be replaced with mu, whose value is actually 0.2. So I press enter to this. Also, I would like the second row, which is actually 0 and first row here, and 0th column to reach to this location, comma 0, close box bracket, and now I also want it to be equal to V, our Poisson ratio. Now I want this location, which is actually 2 cross 2 in 3 by 3 matrix. It will be 0, 0, 1, and second, and number 2 row, and 0, 1, and number 2 column. So I will write A box bracket open 2 comma 2 box bracket closed equals to 1 divided by 2 multiplied by parenthesis open 1 minus mu, or for us it was V, parenthesis closed, and now I say enter to this. So V is 0.2, so 1 minus 0.2 will be 0.8, and half of 0.8 is 0.4. Now let's see what we have in matrix A. So now this time we have created this part of this stiffness, which is 1, Poisson 0, Poisson 1, 0, 0, 0, and 0.4. So we have the same matrix. So this was about this example. The next thing, we can also create a matrix of zeros by simply writing empty and the size of the matrix. So for example, if I want a matrix A, which should be NumPy dot empty, but this time in parentheses I want a matrix which has 4 rows but 9 columns in it, and all of them should be 0. And I press enter to this, and we get an error. And it says the data type is not understood. So let's retype and see how to resolve this problem. So I'm writing again a dot and a equals to and numpy dot an empty matrix, and when I open the parenthesis, it tells actually we have to enter the shape here first of all. And as we did earlier, the shape has to be written within parentheses. So let me this time write in parentheses 4, 9 and close the parentheses. Now this is the shape of the matrix which tells 4 by 9 matrix. And now we close the parentheses for the empty function. Now press enter to this. So this seems working. And let's see what we have in A. So it has not filled it with any values. So whatever was already in the computer's memory, it is just filled with that garbage value. So I was wrong in writing here that this is how you can create a matrix with zeros. If you want to create a matrix with zeros, you have to write numpy full 2 by 2 comma 0 here, for example. So let's move to the issue of copying and viewing an array, which is like A equals to numpy dot full within parentheses the size of the matrix 4 by 9. It should also be closed within parenthesis itself, and then comma, what value we want, and we want all to be filled with 0, and we'll press enter to this and see we have all 0 matrix. Now about the copying and viewing, what is the difference? So if this is matrix A, and if for example I say B equals to A, and I press enter and check what is in B, so we can see that A and B has the same value as A. But let me do one thing. Let me say if the second row and second column of A, which is A 1, 1, because the column counting starts from 0 onwards. Now if I say its value is equal to 12, for example, so I now see what is the matrix A, and we can see that its location value has changed. But above we said B equals to A. So let me see what is in B now. B is actually exactly equal to A. Whatever change we do in A, B has the same change in it. So this means that B and A are actually talking about the same location in the computer memory. If we change anything in B, that will also change A, and if we change anything in A, that will also change in B. This means A and B are not a copy of each other, but they are actually the same thing. But if we want to have a copy of A stored in B, which means that if we change A, nothing happens to B because B will just be a copy of A. So if you want to do that, we should write B is equal to A dot copy. And within parentheses, we can keep it blank and then press enter to this. Now let's say what is A is the same matrix as before. This time B seems to be the same. But this time, let's also now change the value of A. This, which is the third row and third column value, for example, 2, 2, that's very close. Let us change it to 35.6, for example. I press enter to this, and now check A matrix. Yes, it has changed. Notice we tried to store a float value in a matrix, which is a matrix of integers, and in array, all of them should have to be same type. So in an existing matrix of integers, we cannot store a float. So we have to actually convert it into float before we store float values in it. But if it would have been a list of numbers, we could have stored any type in it anywhere we like. So let's see what we have in B now, because B is not exactly A, but it's a copy of A. So it is preserved. B is now a different copy of A because we created it by saying B is equal to the copy of A. But if we say B equals to A, this will not create a copy, but it will, both of them will start talking about the same matrix. So we can also use B dot view A is equal to B dot view and press enter. And if we say A and now check its values, A used to have 35 here, but this time it is now replaced with B. B 2, 2 equals to 5, and check what we have in B now, and now check what we have in A. So A has also changed. So this means that A and B both view same location in the computer memory. So if we change anything in A, this means this B is also seeing the same location, so B will change too. Or oppositely, if we change B, it will change the location of A as well. This means if you write A equals to B, or if you write A is equal to B dot view, both actually means the same thing. Now, if you remember, we created a matrix called a list called WC, which had all the different liters per capita per day water consumption used in 5 different houses in Peshawar University area. And because we created an array of it, we can now take benefit of mean, median, max, minimum, and standard deviation functions of array to find out the statistical status of this data. So in this case, first of all, we say WC dot mean, parentheses open and closed, enter. It is 134. WC dot max, parentheses open and closed, press enter. This is the maximum value in it. If we say WC dot min, parentheses open and closed, the minimum in this WC dot standard deviation. So we have that 38.39 in the data. So now let's read a file, which is a CSV comma separated value file. And this time I'll take an example of a road cross section. So here in this data file, we have 3 columns in it. The first column is the location of the road section on the road section. For example, here on x-axis from 0 towards left we have negative values, and towards right we have positive values. We have about 21 readings from left to right, from -100, -90, -80, all the way to 0 in the center, and all the way to 70, 80, 90, and 100 on the right side of the road cross section. So this is the orange color is the road cross section, which is actually the column C here. So you can see that at -100 location, the road is higher than the natural ground, which is green, and it is in column B. So in column B, it is 230 meters above sea level. You can see in green, it is at level 230 above sea level, while the orange point is 10 meters above it. So here you can see here green portion, the natural ground is above the road. So this means here the ground need to be cut to construct this road. While here you can see the natural ground is below the orange road. This means here this portion need to be filled with some soil to construct the road at this location. And here we also have some material that need to be cut to create this beautiful orange cross section of the road. So let's see this file, how this data is stored in CSV file. Comma separated values file is a special Microsoft Excel format. So in my folder, I've stored this file here. I'll open Notepad and I drag this file in Notepad to see how data is stored in it. Now notice the same columns are now written separated by semicolon here. So it is not a comma separated file, actually it is a semicolon separated file. If there were commas here like this, for example, we can call it as a proper comma separated file. If there are spaces here only, it is a space separated file, or if there are tabs here like this, it will be tab separated file. But for us, this particular CSV file is actually semicolon separated, so we have noticed that now. And also, if you see, it has all those points, 21 points in it stored in this form. So let me close this now and do not save it. And as we know the type of data in it, let us try to access this data and use it for some purpose using NumPy's generate from text function. So first we need the location of this file. So on this folder, I click here. This is the location of the file. I copy the location and I know the name of the file is road space section.csv. So in Spider, I've already imported NumPy. So what I will do now is I will write row data, I'll just simply say RD is equal to NumPy and v dot generate from text, which will be gen from text, parentheses open, and in inverted quotation marks, I will write the location of the file, and / the name of the file was road space section dot CSV. I now close the quotation here, and with comma I'll write that the data is delimited equal to by what? By a semicolon. So this semicolon should also be closed in quotation marks. Now if it was a comma separated file, I could have written comma here. If it is a space separated file, I could have written space here. Or if it is a tab separated file, I could have written a tab here like this. But for now it is semicolon, so I'll simply write semicolon here, and then I close the parentheses here and press enter. It gives us an error because the file names should not have backslashes here, it should have forward slashes here. So let me correct this file name string by replacing this with forward slash. And now I press enter to this. And we have an error here because instead of writing the delimiter here, I have written delimited. It should be R here. So we are telling that the delimiter used is semicolon. Now I press. So now with forward slashes and with delimiter corrected here, I pressed enter and the value has been accepted. Now let's see what we have in variable RD. So if I type RD and press enter, so we can see it is an array which is full of all the 3 columns and 21 rows. So now if I want to get only a first column of this, so I'll say A is equal to RD matrix and it's all rows, comma, but 0th column, parenthesis box bracket closed, and press enter to this. Let's see what we have in A now. So A has all the first column stored in matrix A. Now if we want to save an array in a file, so for example the array WC, I want to store it in a file called water consumption, I will say np numpy dot save txt, and then in parentheses in first quotation marks I'll write the location where I want to save it. For example, I want to save this in the same location. I copy this link and I paste this here, and of course making sure it is not backslash but forward slashes being corrected. And now I want to save it in forward slash in a file called wc dot either CSV if I want comma separated values or in it, or if I want I can write txt just if I want to open it in notepad, but I want to open it in Excel, so I write just CSV, and then of course with comma what matrix I want to store in this file. I want to store WC in it, which is water consumption, with comma what delimiter should be used to save it. I write delimiter spelling corrected equals to, I want semicolon to be used again, and now I'll close the parenthesis and press enter to this. So this time if I go to this folder and check for file WC, it would have been stored there. So let's go there and go down and alphabetically right at the bottom perhaps. Yes, it's stored and it's already showing Excel format. I first of all open Notepad and drag this file. So all this is stored without any semicolon because it was only a one column value, and they were floats, so they are stored in this form. Let me close this. Let me double click it to see how it is stored and how it will get shown in Excel. So this is how all these values are stored in first column. Let me close it, and this completes all this discussion. So now in the class you have to do this exercise, that the same data that we have just loaded, where in column B we have the natural ground data, in column A we had the locations, in column C we had the actual orange colored road cross section from this file. Just load it in the same way as we loaded today. What you have to do is you have to create another array for all these 21 locations, but instead of the column B and C, you have to find the location where ground need to be cut or filled for building this road. And the hint is that if you subtract column B from C, which is the natural ground from the final formation level of the road, you will see negative and positive values in them. So if there are negative values in it, this means this is the location where you need to cut. But if it has positive values in it, like this, you will know that these are the locations where we need to fill the ground. So you have remaining lecture time to complete this task in lab right now. This concludes this lecture. Thank you very much.